All right, so let's start our Unit 3 Part 2 mini unit. So before we get into the unit, I want to recap on a few things. The first thing is how to solve a proportion. So if you have like 2/10 equals x over 5. So there's a few different ways to solve this, but I'm just going to do the most basic way that works every time. So you may remember this from years past, but you multiply diagonally. So this would be like 2 times 5, and this would be 10 times x. Okay, so then you would, that 10 times x is of course just 10x, and then 2 times 5 is 10. And then you're able to divide both sides by 10, so x in this case was 1. Okay, let's do one more. I'm going to make this one up off the top of my head too, so who knows how it's going to go. Let's do 3 over 7 is equal to, let's see, 9 over x. Okay, so we're going to do the same thing. We're going to multiply diagonally. So 9 times 7 is 63. And then equals 3x. Divide both sides by 3. And then that would be 21 equals x. So on these, it's a lot of multiplication and division, but it's pretty straightforward. Use a calculator if you need to. No shame in it. I will definitely be using a calculator because some of these numbers get pretty hairy. So let's go back to what similar polygons are. So the word similar in math means the same, if I can type or write, same shape, but not the same size. For example, in our little picture at the beginning, these two figures are the same shape, but they're not the same size. One thing that you do need to know about this is the angle measures. M-E-A-S-U-R. Yeah, it looks weird, but I spelled it right. The angle measures are congruent in similar polygons, and then the side lengths are proportional. And I'm going to get into what proportional means in just a bit. Okay, so now and then we're also going to be talking about scale factor, but I'm going to wait and just start with this stuff. So in the diagram, triangle ABC, and then they give you this little squiggle right here to triangle DEF. Well, this little squiggle, that means, right here, this means similar. Okay, so if you see that little squiggle, it's different than congruent. It's the same shape, but not the same size. So first they want us to do is list all pairs of congruent angles. You know me, I'm going to ask you to color code it. This one's pretty straightforward, but sometimes they're flipped around and reversed and all sorts of stuff. So let's just go ahead and color code it. So A's corresponding angle will be D. B's corresponding angle will be E. And then C and F are corresponding. So since they told you that these shapes are similar, those angles are congruent. So they want you to list part A, the congruent angles. So that would be angle A is congruent to angle D. Angle B is congruent to angle E. And angle C is congruent to angle F. Okay, so that's part A is done. And now B, they want us to check the ratios of corresponding side lengths are equal. So let's talk about this. How many sides do they have? Each triangle has 3. So you're going to have 3 different proportions. So we have a small triangle and a big triangle. it doesn't matter which one you put on top, but I always write it down. Let's do small over the big sides. So if I say 10 on the small triangle corresponds to what side on the big triangle? Well, that would be 15. Okay, if I say 8 on the small triangle, that would correspond to 12. And then 12 on the small triangle would correspond to 18. So now they want you to see if these side lengths are equal. Well, these are all fractions. They could be equal, we don't know. The only way to find out is to reduce them, or simplify, whatever you want to call it. So we have to reduce. So 10/15, you can divide both of those by 5. So that becomes 2/3. 8 and 12, you can divide both of those by 4. So that's 2/3. And 12/18, you can divide both of them by 6. And that's 2/3. And if you are struggling with how to reduce fractions, if you're terrible about it, there is a calculator trick. And if you're in class, I probably have showed you. Or if you're not able to be in class and that's the reason you're watching this video, ask me in class and I will show you. And it's super easy to use. And it just, if you struggle with reducing, it just makes your life easier. Or maybe you don't struggle and you just want to know the trick. I have used it a lot. So, are all of these side lengths equal? Well, they all reduce down to 2/3, so yeah, they are. Okay, and so now C, we have to write a statement of proportionality. Okay, a statement of proportionality. And the homework is going to ask you to do this, and so this is why I'm writing it down what exactly it is that we're doing. So you're going to have 3 sides again. And then let's just do small to big again. And now they want you to write, instead of the measurements, they want you to write the letters that describe the side. So like side AB corresponds to side DE. And then side BC corresponds to EF. And then CA corresponds to FD on the big triangle. So if they want a statement of proportionality in the homework, this is exactly what they're asking for. All right, let's go ahead and move on. So this one is a very similar problem. They want you to list all the pairs of congruent angles and then write their ratios of corresponding side lengths in a statement of proportionality, which is what we just did. So here's the thing. They don't give you the pictures. You have to see it just from the similarity statement. So just from this. And we've done this before with congruent triangles, so it's nothing new. It's just a little different. So let's first list the congruent angles. So that would be angle P is congruent to angle what? Well, let me erase this really fast. And then I forgot to highlight or color code it because we're, you know me, we got to color code everything. So let's color code our angles. So P goes with X, Q goes with Y, and R goes with Z. So P, I said the angle P would be congruent to angle X. Angle Q would be congruent with which angle? Y. And then angle R would be congruent with angle Z. Okay, so they want you to list the pairs of congruent angles. Check, we did that. Now they want us to write the statement of proportionality, which looks like this one that I boxed. Oops. So let's go ahead and do that. We're going to have to do it just by using the letters. It's okay. We can do it. Let's say this is the first triangle and this is the second triangle. So let's do first over second. So a side on the first triangle would be PQ. So that was green then yellow. Then I'm going to do the same thing on the second side. Green then yellow, that would be XY. Then let's do the side QR. That would be congruent with YZ. And the last one would be PR, and that would be congruent, or similar, I shouldn't say congruent, proportionate or similar to xz. Okay, so that's all they want from us on that problem. Let's go ahead and move on to the next one. So determine whether the polygons are similar. If they are, write a similarity statement and then find the scale factor. Okay, before we get into all of that, let's first determine if they are similar. So in order for them to be similar, they have to have congruent angles. Do they have congruent angles? Yes, they do. They're marked for us. Okay, so we can say that's true. All right. Now we have to see if the sides are proportional, like we did on the last or two problems ago. So let's check. Let's say the top. Okay, let's do big to small. Big over small. It doesn't matter which one we do. So we're gonna let's pick the top. We're gonna have 4 sides. Kind of ran out of room. That's okay. I'm writing too big. So let's do the top side, which is 14 on the big one, to the top side on the small one, which is 8. Let's do the left side on the big one, 21. Left side on the small one is 12. Bottom side on the big one is 14. Bottom on the little is 8. And then the right side would be 14 on the big one and 8 on the little one. So if these are proportionate, or if they're similar, then these will all reduce to the same fraction. So 14 and 8, what can you divide both of those by? 2. So that would become 7 over 4. 21 and 12, that can be divided by 3. So that would be 7 and 4. And then 14 over 8, we've already done that one. Becomes 7/4, and the same here, 7/4. So are these proportionate? Yes, they are. So they are similar. So we now have to write a similarity statement. So the similarity statement is, it looks something like this right here. So that's what we're going to do. One figure, and then we're going to do a squiggle is similar to the other figure. The order does matter on this, so you have to line them up. So the similarity statement looks like this. So we're going to do something is similar to something, and we're going to match up the angles. I didn't color code it this time. I probably should have, but we're just going to move on. So A on the small figure, I'll do small to big, is similar to which angle on the big one? Or that would be J. B goes with which one on the big one? That would be K. And then C would go with L, and D would go with M. So notice the order does matter. You can have them in the different order as long as the A and J are in the same place, the B and K are in the same place, C and L, and D and M. Okay, so that is your similarity statement. Now we get to do the scale factor. So they ask for the scale factor a certain way. So the scale factor on this one is the figure ABC, which is the small, to JKLM, which is the big. So they want the scale factor of small over big. No big deal. So you're going to pick one side. You don't need to do all 4. You can if you really want to, but it's not necessary. Pick one side on each one. I'm going to pick the top side. So the top side is 8 on the small one and 14 on the big one. And then they want, on the scale factor, you always have to reduce. So always reduce if you can. If you can't, then you can't, but always reduce if you can. So your scale factor is going to equal, we already said, 4/7. So this is your scale factor is 4/7. Could you have said 7/4 like we did up here? The answer is no, because they asked it for small to big. This here, right here, tells you which number to put on top or bottom. So you got to pay attention to that. The order does matter. All right, here's another one. So in the diagram, they're similar. Find the value of x. So now we're going to set up those proportions, which is what I started this lesson off with. So it doesn't matter how you set this up. let's do small over big. And this time we don't need to do all 3 sides, we only need to do 2. And since we're solving for x, let's just start there. So x will be on bottom, and x's corresponding side on the small one would be how much? 13. Okay, now you just have to pick one of the other 2 sides. It doesn't matter which one. So I'm going to do the bottom ones because they're smaller numbers. That's the only reason. So 5 on the small one is corresponding to 10 on the big one. So if we did this and we multiplied it out diagonally, that would give you 5x equals 130. Then you would divide both sides by 5, so x would equal 26. And that is the answer. So say you didn't use 5/10, would you have gotten the same answer? And the answer is yes. So I'm going to do 13 over x again. So big or small to big is going to be equal. Instead of using 5 this time, I'm going to use 12 to 24. So when you solve this, and I just put it in a calculator, that would give you 12x is going to equal 312. But that's what 13 times 24 is. Again, if this is on your homework, use your calculator. No need to do 2-digit by 2-digit multiplication unless you really want to. All right, go ahead and divide both sides by 12. Again, use your calculator. And looky there, you get x equals 26. So you get the same answer either way. If you use either side you used, just use whichever one you want. I tend to try to use the smaller ones if I can because they're just easy to work with, but you'll get the same answer. Okay, now the next one. What is the scale factor of element P to FJ or FGHJ? So that looks like we have a small figure and a big figure. So they want the scale factor of small to big. Okay. Doesn't matter which side I pick. Yes and no. There's only one side that you absolutely cannot pick to use the scale factor, which is the 40 and the x. And the reason is we don't know what x is yet. I bet they're going to have us find it. Actually, I know they are. So you could use you could use 12 and 15, 16 and 20, or this 12 and 15. It doesn't matter. And they want it small to big. That order matters. So I'm going to use the 12 to 15. So that would be 12 over 15. Do I have to reduce? Yeah, absolutely. You can divide both of those by 3, and that becomes 4/5. And that's your answer. Okay, now let's find the value of x. On this one, it doesn't matter if you set it up small to big to small, you'll still get the same answer. Let's do big to small. Okay, let's start with my x side. So that would be 40 over x is going to equal, let's do the top side again. So that would be 15, as on the big one, is to 12. Okay, so now I need to multiply diagonally, of course. So that would give me 15x is going to equal 480. Then go ahead and divide both sides by 15. 480 divided by 15. Yes, I used a calculator for this. That would give you 32. So that is your answer. That's all you need to do. Okay, we're almost finished. Stick with me. Sorry, this is a long video. There's a lot in this. So now, another thing to know about this is the perimeters of similar polygons are also proportional. So say you have, of course, you have this part over here, this part over here that we've been using that the sides are proportional. So, okay, that's fine. But you can also use the perimeter. So if you have the perimeter of one and they're trying to get you to use the perimeter of the other, then you could put the perimeter over x and then do the corresponding sides with it and set up a proportion that way. You're probably like, what are you talking about? Let's do an example. So on this one, it's a word problem. We're going to draw a picture. A larger cement court is being poured for a basketball hoop in place of a smaller one. The court will be 20 feet wide. Let's draw a picture. and 25 feet long. This is the newer one, right? The old court was smaller, and it was similar in shape, but it was only 16 feet wide. And so 16 will go on the side because it said 20 was wide, so they need to go on the same side. All right, the first thing says to find the scale factor of the new court, so new court to old court. Well, you can only use two numbers here. We can only use 20 and 16 because we don't know what this is, so we can't compare 25 to what is here yet because we don't know what that is. So let's do that. We are going to do new to old, so that would be 20 over 16. You can reduce that, divide both of them by 4, so that becomes 5/4. So that's your scale factor. Done. Okay. Now find the perimeters of the new and the old court. The new one's easy to find, right? We know on this that this is 25 and this is 20. And so we can just add them all up. So the new perimeter, this is part B, is going to be 20 plus 20 plus 25 plus 25, which equals 90. Sweet. So the perimeter is 90. All right, now let's find the old court. So there's a few different ways to go about this, but we're going to just use the proportion to find it. So let's do new over old again. So let's do the new perimeter. Just slid that right there. We already found that. Over the old perimeter, let's call that X. We don't know. That's what we're trying to figure out. Is proportionate to, now you just do one of the sides, and we can only use 20 and 16 because we don't know what that top side is on the old one. So it's proportionate to 20 on the new over 16 on the old. Okay, now we're going to use a calculator to do 16, if I can type it in right, 16 times 90, and then 20 times X. Run out of space. 16 times 90 is 1,440. That's going to equal 20x. Divide both sides by 20, and x equals 72. So the old perimeter is 72. The new perimeter is 90. And the scale factor we already had on part A was 5/4. So we have all the pieces of the problem. Okay, this problem... in the diagram, FGH is similar to JGK. So this triangle is similar to the big triangle. Find the length of the altitude, GL. So altitude would be this distance right there. So let's set this up as a proportion. This is like what the homework is, small to big. So let's do the altitude, that's that vertical line of the big one is X. That's what we're trying to find. What's the altitude of the small one? Well, that would be right here. What is that length? 14. Okay. Now that's proportionate to, we have to do the sides now. So the small side, let's go ahead and use the base of the triangle. Let's use this one and this one. So the base of the small triangle is 5 plus 5, so that give you 10. Over the base of the big one, 8 plus 8, so 16. All right, now we have a proportion all set up. We're ready to just do some good old-fashioned math. So let's go ahead and do this and this. So that would give you 10x is equal to, put in your calculator, 14 times 16. You get 224. All right, divide both sides by 10. And you would get x equals 22.4. Yes, you can have a decimal. It's okay. So don't freak out. It's all right. Is that a realistic measurement? Well, if this is 14, yeah, this distance right here looks like it could be about 22.4. If you got something like 3 as your answer, that's obviously not going to be right. It's not going to be smaller than the other one. And then you're not going to get something like 92 because that's just ridiculous. Okay, we're going to do one more. I'm not going to do number 5 just to save time on this video because it's already long enough. So find the perimeter the perimeter of WXY. So that's the little triangle. So let's set this up as the perimeter of the big over the perimeter of the small. Okay, so let's do big over small. So what's the perimeter of the big? That would be 72 plus 63 plus 81. You betcha I'm going to put that in the calculator so I don't have to think too hard. 72 plus 63 plus 81 is 216. Over the perimeter of the small, well, we don't know what that is yet. That's X. That's what we're trying to figure out. We're still doing big over small. Okay, and now we're going to do a corresponding side. So the only sides we can use on this, because they give us both of them, is 40 and 72, because they don't give us any other sides on the small one. So the big side would be 72, and the little side would be 40. Okay, go ahead and multiply diagonally. That would be 72x, and then 216 times 40. Whew, give you a big number. 8,640. All right, last step. Divide by 72. That gives you x equals 120. Yeah, that's a realistic number. So the perimeter of the small one is 120. All right, that's it for this video. I'm sorry it was so long, but thanks for watching. I hope you enjoyed it. This stuff is fun to me, so have a great rest of your day.